in 1.1, we're looking at recursively defined sequences. So, example A, we've got a diagram to show exactly what we're looking at, but a square table seats 4 people, 2 square tables pushed together seat 6 people, 3 tables pushed together seat 8 people. And we are asked how many people can sit at 10 tables pushed together, how many tables are needed to sit 32 people, and to write a recursive definition to find the number of people who can sit at any linear arrangement of square tables. Okay, so what we're going to do first is set up our pattern. Okay, and to do so, we're going to start a table. So we're looking at the number of seats, the number of tables that are pushed together versus the number of seats. And like we were told in the story problem, and we can look here in our diagram, 1 table holds 4, 2, 6, and 3 tables hold 8. Okay? And what we should find is a constant change happening. If we go from 4 to 6, we add 2. If we go from 6 to 8, we add 2. So if we wanted to find the 4th table, we would add 2 again. Okay? But we are asked to find the 10th table. So we can just add 2 until we get to the 10th term, or the 10th table. Okay? So if we think about it from going from the 4th table to the 10th table, we have to go 6 more tables, adding 2 each time. That means we actually have to add 12 to 10. So we have a total of 22 seats at the 10th table. Okay. Then we are asked to find how many tables are needed to seat 32 people. Okay. So if we already know that 10 tables seat 22, I know to get to 32 people, that's an additional 10 chairs. And before, we already said each table we add 2 chairs. So that means we're not adding 10 tables to get from 22 to 32, but we're adding 5 tables. So adding 5 tables to the 10 that we already had, that's 15 tables. Okay? You can think ahead like that, or you can just continue to fill out the table all the way up to 10 tables, and then for the second part of our question, fill up the table until you get 32 people in a seat. Then we need to write a recursive routine. Now, to write a recursive routine, we always need a starting point. So our starting point here was 1 table seated 4 people. Okay, it always is a sub. If this is our first term or a 1 table, there's a 1 below, and 4 is the value that goes along with that first term. Okay. And then we need to write a rule. So we say a sub n, that means any term equals a sub n minus 1. That means the previous term. And we already said we were adding 2 each time. Okay. So you might want to jot this down just so you remember. This is our first term. This is any term. And this is the previous term. And then the plus 2 was that constant change that we found happening from each term to the next. Okay? And when we come in on class on Monday, we are going to look at how to make a shortcut for recursive routines using our calculator.